All right, algebra students, my name is Miss Schaefer. For those of you who don't know me, hello to Mr. Blom's class and also to Miss Tryon's class. So bear with me, this is my first video, so hopefully you enjoy it. You should know what to do though, you got another booklet. So what we're doing today is defining a function. So we're going to check that one off right there. All right, and then moving on. Our first thing with defining a function, before that, we need to understand what a mathematical relationship is. So a mathematical relationship is, let's go down here, a relationship in math is a connection between at least two quantities. So sometimes there will be more than two quantities, but mostly what we're going to focus on is just going to be two quantities and the connections between those. So some examples of all of that. Looking down here, we've got one being the number of hours you work, so time, and then that's related to the amount of money that you make. Okay, so you go into work to work a shift, you get so much money an hour. The amount of pay that you get is directly dependent on the amount of time that you're there working. Okay, another example could be the amount of calories you consume and how much weight you would gain or lose. So a lot of times, you know, they say like a 2,000 calorie diet or something like that, and it varies for person to person, but if you eat more calories, you're going to gain more weight. If you eat less calories, you're going to lose weight. That's the idea there. Moving on down, when you're thinking of these relationships, each amount is thought of as a variable just because those numbers can change. So when you're working and you have a certain amount of hours you can work, that can change from shift to shift, right? It's not going to be the same every time. Just like the amount of money that you make isn't going to be the same every time either. Same thing like with the food, the calories, and the amount of weight you gain or lose. Those things are always going to be changed. So that's why they're variables. Variable stands, for something that's changing, a value that can change. We have two very important variables. So what we need to remember are there we go. Okay, the dependent variable changes in response to the independent variable. Okay, so we have independent and dependent variables, and you just have to remember that the dependent one is the one that changes based on the independent variable. So looking back up at our examples up here, looking at this first one with time and money and the relationship with how much you work and how much money you make, what do you think is going to be the independent variable? Just think to yourself for a second. Okay, and then the dependent variable, think of that one. That one is changing based on the independent variable. All right, so hopefully you were correct. The independent variable should be the time, and the dependent one should be the money. That's IND and DEP just for independent and dependent, just so you know. You don't have to write that down. It might be a good idea, but just to let you know. And then what about for the amount of calories we consume and how much weight we would gain or lose? Which one do you think was going to be the independent versus the dependent? Which one's going to change based on the other? Your weight. Your weight is going to change based on the amount of calories you consume. So that's going to be your dependent variable, and the calories you consume would be your independent variable. Okay. Moving on down, there are two other very important things down here that you need to pay attention to. So now that we know how to find our independent and dependent variables, you need to remember that independent is what's going to be our input for our functions, okay? And dependent is what's going to be your output, okay? So think of it like you clock in at work and you put in so many hours, and then the result is like your output. The result is how much money you make. So that's going to be the dependent variable, which should be your output. Okay. And a very big thing then to remember For a function is a relationship, but it has to have this specific thing with it. It has to be such that every input value is paired with exactly one output. Okay, so a function is a relationship that pairs each input value with exactly one output value. That's going to be the key definition of a function that you need to know. All right. Moving to the next page. Defining a function continued, page 2. We have this nice handy dandy little function machine graphic here. We'll explain that a little bit more on the next section, but that's just to kind of help you again think of you're putting in an input, okay? A function is doing something with that input and then spitting out a different value as the output. So we're going to be calling our functions mostly f. Doesn't always have to be f, but it will be f most of the time, and it's just, you know, f for function, okay? And x is usually the variable that we're going to use for our input. Again, it can be other values, but x is the most common. And then what we're going to call the output, or the actual like function, is going to be like f of x. So those parentheses here doesn't mean f multiplied by x. It means like f of x. It's like you're plugging that x in to the function, okay? So we can think of functions in a few different ways. One way is written, okay? This guy right here. So an example of a written example for a function would be like an arcade machine. So let's say you go and you need to put in money to get tokens, and for each dollar you get out 10 tokens from the machine. Okay, so every time you put in a different amount of dollars, you're going to get a different amount of coins. So if you put in $2, 20 coins and stuff like that. But something that wouldn't be a function would be like a slot machine. Okay, you could think of your input as like every time you pull or push the button, depending on what kind of slot machine you're using. And then your output is some amount of money, but it's never usually the same amount of money. A lot of times it's zero money, or maybe you get $100 or $50 or $2 or something outrageous. Okay, so every time you do that input, you're getting out a different output value. So it's not paired with exactly one, it's paired with a bunch of different output values. So that's not going to be a function. Unlike the arcade machine, every time you put in $1, it's always going to be that 10 tokens. So 1 is always paired with 10, and then $2 would be paired with 20 tokens, and so forth. But it's always that same amount. Never going to change. Okay, and then our second example, or way that we can look at a function, would be a table. So usually we have an input side and an output side. Sometimes you'll see those as like x and f of x. So I'll write that in down here for you. Okay, you might see x and then f of x for your function output. So let's look at this example. We've got 1 being paired with 7. So for some scenario, we're putting in 1 and we're getting out 7. Okay, you put in 2 and you get 10. Put in 3 and you get 13. Okay, so what is important to notice here is that these values on the input side, okay, aren't repeating with like different output numbers. Okay, so like on this example over here, let's look at that. We've got an input of 1, 1, and 1, so we're putting in that same input, but your output is different. So 1's being paired with 3, 1's being paired with 5, 1's being paired with 4. But 1 should only be paired with one value if it's a function. So that's what makes this not a function. Over here, you've just got 1 being paired with 7, 2 with 10, 3 with 13, so that's fine. Okay, every one of those input values is being paired with one output value. And something else to notice here too, a lot of students get tricked up on is you can have repeating output values. So I could have, like, I'm going to add in on this guy down here. Let's add another like row. Okay, let's say we put in 4, and for some reason we get 10 again. That's okay, as long as your inputs aren't the same and have different outputs. Okay, then you're fine. But since we have another input, and even though it's the same output as what 2 was, that's okay, because it only has to be the input that's paired with only one output, but different output values can happen for different input values. Hopefully that makes sense. We'll have to probably talk about that more in our classes together. The last way we can look at a function is a graph. So what we've got here is an example that is a function. So we've got time down at our bottom and temperature on the other axis there. And we've got whatever our function is doing on the graph there. Okay, so something that is a function is going to pass what we call the vertical line test. So I'll write that in for you down here. I would write this down too. Vertical line test. Okay, and what that's going to be is that if it's a function, a vertical line should only cross your function once. So any vertical line should cross or intersect a function once. That's kind of an ugly E, sorry. Once is what that says if you can't read it. Okay, so what I mean by that is taking a look up here at our actual picture of our function. Okay, I'm actually going to put this down and let's just scroll up a little bit. There we go. Okay, if I take a vertical line and I draw it through, and it cuts through my function, it only hits it in one spot. Okay, and I can do that anywhere, and it's only going to intersect my function at one spot. So that's what we kind of mean with the vertical line test. The example of not being a function over here, like if I draw a vertical line through here, it's going to hit both of those points. Okay, that's bad. Same thing right here. It's going to hit both of those points. And the reason that is happening is with that input being paired with only one output kind of thing. So down here, our time, that's your independent variable. That is your input. So let's put that in there. This is our input. Okay, or you can think of it as your independent, whoops, not D. There we go. Meant to be a V, so to stand for independent variable. Okay, and then your temperature over here is what your output is. So there we go. And that's going to be, again, your dependent variable. Okay, so looking at that, maybe let's zoom in a little bit. There. So every time I have an input value, let's say 5, and I go up, there's only one spot where that function is for 5, okay? It's only 1 degree. It's not like down here and then also up here or something like that. Like your function doesn't look something like this, okay? Where like I would have different output values for every input, okay? If you have that happening, that's what's happening over on this side. Okay, if I have my input here, whatever number I'm pushing into a machine or whatever it is, and then I get a color out, well, let's say I put in 1 and I get blue, and I also get red at a separate time that I push number 1. That input of 1 is being paired with 2 different outputs. That's bad, okay? It's not a function. Same with all of these other ones. And that's what makes it have the failing of the vertical line test, because if there is one input being paired with different outputs, that vertical line is going to hit it twice or more times than that, depending on how many output values your input is paired with. Okay, and then also too, just to remember, typically usually your x-axis is going to be your input all the time. Okay, that's usually how we write things. And then the dependent or the output is going to be on the vertical axis. And we'll take a look at a little bit more of that later. All right, so that should be it for the first lesson. Hopefully it went well. If you have any questions, be sure to ask your teacher. If I'm your teacher, just check in with me like we normally do. But good luck at working on the assignment for this lesson.